Okay, so in this tutorial, we are going to build a complex curved wall in Revit and trace it all the way through the fabrication process. So the project that we're looking at is a student design project, and it's building from a simple idea of a sort of two-dimensionally curved wall, something like this. But where the student project is wanting to go is something that begins to look at emulating a curve on the wall, both inside and outside. So not only is the wall curving along an edge, but it's actually bowing this way. So this was a model that was beginning to attempt to illustrate what that idea would be and how it would sort of begin carving back into the building. So to build a wall like that, there's really not a wall tool that we can begin to use to start bending and bowing the wall shapes. We need to go into the massing tools. And we need to go a little bit further than that as well, because we also want the wall, if we want it to curve to the inside and not just conform to whatever the shape outside is, we actually need to entirely replace one of these wall elements with a brand new massing object. So the first thing that I'm doing is actually giving myself a little bit of a template, a two-dimensional template to work with. And the easiest way to do that, what I did with this wall right here, is just to select one of the wall. This is already set to a length and height that I can begin working with, and click Edit Profile. From Edit Profile, I'm going to use the Spline tool and draw out the basic shapes that I'm wanting. And then with the spline tool, you've probably already realized if you've worked with Revit, the spline tool, I cannot run the trim command to select something, to reattach something to a spline. So I need to simply come back in and erase all of those edge lines and replace them with new lines. So not too much to complain about, really. Just go back and do it quickly. So I have this as the new profile for my wall, which gives me this kind of result. And again, anytime we're building this kind of connection, this is going to be a tricky thing to do. And I'm not going to try and build both of these. For right now, we want to look at a basic method of just building a single piece. And we're going to be using the massing tool, or the custom massing underneath custom component. And we'll be using a technique called lofting, which is something that a lot of Revit users are not familiar with yet. So let's go ahead and launch Model in Place. And I'm going to select the Mass tool. This gives us a different set of modeling tools, which includes a method called lofting in terms of building, selecting a series of different profiles to put together a very complex object. So inside of this, what I'm going to do is navigate to my level 1 floor plan. And I'm going to switch my visibility mode to wireframe, simply so that I can see exactly where my initial footprint is going to be touching the edge. Because remember, my floor plan views are 4 feet. It's a cut 4 feet above the level that I'm currently on. So if I look at this in an elevations, travel to the south elevation, my floor plan view is a section cut 4 feet above level 1 looking down. So switching my mode to wireframe actually gives me these inside lines so I can be closer to the location where they actually come in contact with the ground. So I'm going to use the spline tool, and I'm drawing on my level 1 reference plane. Again, I'm not going to worry about a really intense level of precision here in terms of exactly where my curves land, but I do want to put something together that begins to build the right form of accuracy for me. So I'm going to do 6 points, like that, and then double tap escape to drop the line command, and I'm going to do 6 points, another spline on the opposite side with a slight different form. Now, in this particular case, there's no magic number with 6. I just want to remember how many points that I have. 1, 2, 3, 4, 5, 6 across, simply so that I can begin to have the same kind of form each level going up. It's actually 7 points. 1, 2, 3, 4, 5, 6, 7. I guess I did 7 and 1, 2, 3, 4, 5, 6, 7. Counting, complex stuff. Okay, so I've got my two splines. I'm going to connect these two splines together here and here. And I'm making sure that I've got that endpoint connected so that I have a complete loop. Okay, so if I hover over this before I select it, I've got a complete loop. So if we go to my 3D view, I can select that loop and click Create Form, and I get a basic extrusion coming together. That's not exactly what I'm wanting because I'm wanting to vary this extrusion on each edge. So I want to copy this loop and then make some variations with it as it goes up. Now, in theory, with the Loft tool, I can actually go up a level and just draw new curves and then connect those two things together. And in general, that does work. But the more complex that I get, the more reliable of a system I need to build as well. So typically what I like to do is work with this exact same profile over and over and make simple modifications to it. That method for me just seems to be a little bit more reliable. So what I'm going to do is select that curve. I'm going to go to my elevation view, and I'm going to copy, and I'm going to move that up off of its current reference plane, level 1. So I need to uncheck constrain. I'm going to select my reference plane, and I'm going to move it up to level 2. So if I look at that in my three-dimensional view, I'm going to change the 3D view to wireframe. I'm going to use the tab key to select the edge, and I'm going to move this edge approximately to the outside edge of that curve. And that is going to reshape the basic properties of those splines. I'm going to do the same thing with this other side. Tab to isolate that, move tool, and again I'm going to move it to the approximate inside edge of that curve. So right now I have essentially the same profile, slightly different locations. I'm going to use the tab key again to modify what this curve is doing. So essentially I'm changing the shape of this wall as it moves up. Not being too aggressive with it, but sort of gradually changing that shape as the wall goes up vertically. So the next mistake that I often see people making with the Loft tool is they're really aggressive at going after a very complex form arrangement, and they do all of the pieces and then pray that the Loft tool works. My method is a little bit easier than that and a little bit more reliable. If I break something and the Loft tool doesn't work, I want to know why. So each time I copy up one of these profiles, I'm going to select my base, my next loft, create form, and make sure it works, which that did. That built that form for me. Hidden line view, you can see exactly where it's at. Back to the wireframe. Control Z to undo because I want to get that back to my two base curves. I'm going to go back to my south elevation again. Copy, unconstrain, and I'm going to move this one up approximately to the location that this edge meets. So I'm going to double tap escape to drop my copy tool. I'm going to select my end, move it out. Same thing with this side. Modify the curve. So again, I'm using the tab key to isolate that selection and modify it. Once again, I'm going to select each loft, create form to make sure it's going to work. Control Z to undo. Select, copy, unconstrain, next curve up. Exact same routine again. This edge is already in the right place, so I just need to move this straight line in. And oftentimes it's right about now that I might break. You know, sometimes these lines, these edges might not go with that straight line. That's okay, just hook them back together. You know, you can always select a grip, and a grip is, you know, like this edge right here, and move it exactly where it needs to go. Use the snapping to bring things back together as needed. So again, making some basic variations with this. Actually, I'm going to pull this one back in just a little bit more. And taper it in just a little bit as it's approaching the top of the wall. One more iteration on this. So selecting, elevation view, copy, turn off the constraint, and move that one approximately to that top edge. Looks like I accidentally did 2 copies there. Last time, moving the edges in. Step 1, move. Step 2, and last, modifications to the spline. So what I'm going to do last, you can see I've got these sets of profiles. I'm going to select each profile and run create form. Now you can see this isn't following exactly this curve, so it looks like to me I might need to add in one additional profile right here, so this is actually beginning to sweep back and in a little bit. So let's do that. One more. Control Z. I lied. Thought I was on my last one, but let's do one more. Copy, and so we'll pull this down. Turn off constraint. And move these edges to the right location. So this is still going to curve out, because what Revit is going to do, what the lofting command is going to do, is it's going to look to make the smoothest possible line across this edge. And that's simply a nature of how lofting inside of the program is going to work. To get that really precise level of control, there's a couple of things that we could do. We could come back and actually subtract something out, but that's not going to give us that sort of consistent roll. This is honestly one of those things where I begin to talk with students and say, does that curve, how much does that curve really matter to you? Does it need to be that exact shape? Ultimately, what we need inside of Revit is something like what Fusion has, where we can begin to create a cage and create tension based off of how we want these curves to respond within an overall cage. And I'm pretty sure Revit's going to get there soon. But for right now, we have to just sort of accept, you know, the fact that this is going to curve out and not follow the exact line that we want. So I'm going to say finish to that. And at this point, I can hide my wall that I was using as a basic prototype. And I'm left with this piece. I'm going to turn this back to hidden line, and one of the problems with the massing tool in general is I actually want to use this. I don't want to use wall by face or anything like that. Anything that I do with that is going to give me weird edges. I actually want to use this now from here on as my wall component. So one of the things that I need to do is turn this object, which is currently transparent, into something that's going to resemble my wall material. So to add a material to a component, I actually need to be editing in the family. So I'm going to go select it, edit in place, select the entire object again. Let's just use a large lasso to do that. And right here is my material. And for right now, I'm just going to set it to the default. Just so we can see that that changes it from the typical transparent massing to something that is actually a solid surface now. So I can change that to brick, or I can change it to steel panels, whatever I might want to do that would represent what that material is. So the last thing to show in terms of building this kind of form is how to go back and edit the form. So if I select my object and go to edit in place, I can select my overall form and turn on X-ray. And what X-ray will allow me to do is to come back and select any of these curves. And once I select the curves, I have my control points back in place. And I can take those control points and begin modifying my overall curve to modify the entire overall form. So let's say that I wanted to make a little bit more of a dramatic kind of pinch on the inside. I can select these. And again, I like the idea of adding in a little bit more drama to these curves after I have my base model done, because again, the lofting process is reasonably complicated. Being too aggressive early on, you'll absolutely break the model. And by breaking the model, let me see if I can break it here. So let's do something like that. I'm making a stronger edge coming to the inside. If I push any of these points too far, I should actually begin to get an error message. And the same type of error message is what you see often when you're trying to do lofts the first time. And that's simply a sign that I've pressed something too far. I'm taking some of these points and I'm sort of folding the form back in on itself. And Revit just simply will not let you do that. And for good reason. It becomes an unbuildable form in the real world. So let's go ahead and finish mass. So the last part of this, if I'm doing this for any representation purpose, I also need to get this out of the computer. And you can imagine this is a fairly difficult form to build unless I send it to a 3D printer. So I want to walk through that process as well. So I'm going to select my form, and I'm going to isolate the element. So this form is now living all by itself right here in Revit. And in my add-ins, I have STL Exporter for Revit, and that's a simple plugin you can find for free. Just Google STL Exporter Revit 2017 or whatever version of Revit that you're in, and you should be able to find this. It's a very simple install. So I'm going to run the STL Exporter. I'm going to accept all the defaults and hit save. And I'm going to send this just to my desktop for now. Curve 1. Now, the STL format is stereolithography, and so I can bring that into my 3D printing software, which in this case is going to be Cura for Lulzbot. We run a couple of TAS5 machines as our 3D printers. They are rock solid, excellent machines, really, really good to use. So I'm going to come in and load in Curve 1. Now the next thing I need to do, and I forgot to launch Excel, so take me just a second here, is I need to make sure that I'm working at a scale. Moving from Revit into Cura, I have a basic problem where what I had in Revit, a base unit was feet, so 111 would have represented 1 foot distributed across the X, Y, and Z axis. That 1, and 1 now represents a millimeter and a millimeter and a millimeter. So everything has been sort of drastically sized down. So I need to get this to an 1/8 inch model. So we've built an Excel spreadsheet which simply gives an input value. 1 inch equals 8 feet for an 1/8 inch model, and that updates based on where I'm sending this to, what my scale value should be. So you can simply see a real simple equation right here that begins to establish what my scale factors are. So I need to increase this by 317.37%. So in Cura, that process is selecting my object, selecting scale, and I only need to do this for one of my values, 3.1737. Enter. So it's going to rerun the slicing. And now I have this piece ready to print. It's going to take 2 hours and 58 minutes, which is really not bad at all. And the profile, I can tell you a little bit about the profile we're using. We're using the default profile for engine material. It's a recycled polyester. It's a great filament to work with. And the primary modifications that I'm making on something like this for an architectural model like this, I really don't need any infill at all. Maybe I'll do a 5% infill. And then the default layer height is 0.18 millimeters. And that's really the big time saver, is changing this from a 0.18 millimeters to 0.3 millimeters. So if I drop that back down to the default 1.8, you can see this becomes about an 8-hour print if I remember correctly. And we really don't need that level of detail for an architectural study model. For something final, maybe we need that 5.5 hours. That's not bad, but the quality difference, setting that to 0.3, and that's how many layers that I have, will be perfectly fine for an architectural model. So if I switch my view mode to layers, you can see a little bit more information about how that's going to print, just like that. So you can see a little bit of where that infill is going to happen and how that will give me just a little bit more structural integrity in terms of that form. Maybe it's worth that 26 extra minutes. So the final output, this was where our model was at. We're looking to replace these pieces, and we start to get this kind of shape. And this is printed with sort of our test filament that we use, which is transparent. I'm going to switch this out to a white filament for the final model, but that gives you an idea of what we can begin to do a better visualization on this particular model.